Okay, number 4. Let's have a look at this one now. So 2 cos theta is equal to -1. Let's forget about that domain to start with and just deal with the question. So I only want cos theta. So what I need to do is divide both sides by 2. What I'm going to end up with is cos theta is equal to -1/2. Let's forget about the minus in front of the half, and we'll come back to that. And let's find what theta equals. So theta is inverse cos, or cos to the -1 of 1/2. Pop that into your calculators, or as you will probably remember, the half or the 1 and 2 are numbers in our special triangles, so we could use those as well. What we end up with is theta is equal to 60 degrees. Okay, so that's taken care of our first quadrant answer, but let's now have a look back at that minus sign that was in front of the half. That tells us that cos was negative. So let's have a look at these. All stations to central. Pop in our degrees so we can remember those. Okay, cos was negative. So where is cos negative? Cos is negative in the second quadrant and the third quadrant, okay? Because all symbols are positive in the start, and in the fourth quadrant cos is. So it's in the second and third quadrant that cos is negative. So what happens there, we end up with a 180 minus theta in the third quadrant and a 180 plus theta for our fourth quadrant. So let's have a look at what values we want to get for our theta. So we want 180 minus 60, and we want 180 plus 60 degrees. So what we end up with is theta being equal to 120 degrees, theta also being equal to 240 degrees. Okay, now that, however, is not our answer. That's what our answer would be if we were in our normal domain of 0 less than equal to x is less than equal to 360. Remember, that domain is just one unit circle. Okay, one revolution around, and we've had a little bit of look at restricted domains within that domain. But now, if you have a look at what we've got x being between 360, which is still here, so we've got that end there, and less than or equal to minus 360. So what we'll notice is these two answers are going to be correct. They're still going to be solutions, but we're also going to end up with solutions on the other side of 0. Okay, so when 0 goes down to minus 360 degrees. So let's have a look at what we can do for that. Okay, so without actually looking at what's happening with the cos curve, so straight up, what I could do to get my other two solutions would be to take 360 degrees away from 120 and 360 degrees away from 240 degrees, and that would get me my other two solutions, and that would be fine. But I think it's a lot better to be able to see where it comes from, and I know there's a lot of you in here who want to know why, so let's have a look at the why. I'll go and grab a cos curve. Okay, so our current two solutions are 120 and 240 that I want to pop onto that cos curve. So if I just jump over here, here's my y equals cos of x. That's what it looks like. We're in a unit circle, so we're between 1 and minus 1, and we're just having a look at what happens here. So I said my values were, sorry, I'm going to jump back in because I forgot them, 120 degrees and 240 degrees. So 120 degrees, be around about here, and 240 would be around about here. So they're the solutions I've got at the moment. Okay, and we looked at them on our all stations to central quadrants where that would sit, and we were looking in that case in a domain between 0 and 360, but now our domain is between 360, where are we? Just get another colour there, between 360 and minus 360. So what we've got are two more solutions down there. So if you have a look at where that graph repeats itself, this part that ducks down into the negatives happens over here again. So I'm going to end up with a solution here and a solution here. And what I said was we could take 360 degrees from our two values that we have up here. And this is why, because the graph repeats itself every 360 degrees in this case. So it might be easy to have a look at where this top point here repeats itself. It moves down. We've got 90, 180, 270, and it comes up again, 360. So we have a look at this little point down here for 240. We're going to have it repeat again down here once it goes through one revolution of 360 degrees. So if I take off 360 degrees here and take off 360 degrees here, I'm going to get my values at the other end. So let's have a look at what that's going to be. 120 minus 360 is minus 240 degrees. And 240 take away 360 is going to be minus 120 degrees. So if we jump back into our solution over here, we're also going to get minus 120 degrees and minus 240 degrees. So generally, as a rule, we'd write them in order from smallest to largest. I will do that just over to the side, but you're not going to be incorrect if you don't do that. Minus 240, minus 120, 120 and 240 degrees. Okay, so again, you can do that without your having a sine graph there. You're just taking 360 off each of those, but it's nice to know why. Okay, let's have a look at number 5 and 6. There's a little difference in these from the other two that we've looked at, sorry, the other 4 that we've looked at, in that we're looking for a 2x in here and a 2x in here. The difference there is we normally have a theta or a single x in there. I want to assume to start with that's all it has in there, and then we'll go back and solve it. So I'm going to assume to start with that I'm solving for tan of x is equal to minus root 3. And then we'll go back and we'll replace that x with a 2x at the end and solve that. So we'll pretend it's not there to start with. Okay, let's pretend that it is exactly as it was last time. We're in our normal domain of x between 0 and 360, so it's not going to be a tricky one. Let's find x being the inverse of tan of root 3. Again, we're also not going to look at that minus yet because we look at that when we're looking at our all stations to central. So pop it into your calculator or use your special triangles. Either way, inverse tan of root 3 is 60 degrees. Pop that one in there. Okay, now think what we do next. We have a look at what happens in our quadrants. Okay, all stations to central. You can pop your values on there. So we'll fix that one up. On there if you like, 0, 360, 90, 180 and 270. And we were looking for tan of x is equal to minus root 3. So we're looking where tan is negative. Where is tan negative? Tan is negative in the second quadrant and tan is negative into the fourth quadrant. So we want to have 180 minus theta and we want to have 360 minus theta with theta, or our x, sorry. Either way, x or theta is 60. So we're going to have values for 180 degrees minus 60 and 360 degrees minus 60 as well. That will give us values of 120 degrees and 300 degrees. Okay, now that was for x. So that was solving this part here. Tan of x is equal to minus root 3 within that domain. What have we got? We've got tan of 2x. So a little bit of algebra involved. So x is what we want to get. We're actually saying that we've got 2x equal to 120 degrees and 300 degrees. Can anyone notice something that we haven't done yet? You may not even think about this. Our domain has to change as well. Our domain was x between 0 and 360, but I've now changed that x to a 2x because that's what the question wanted. So our domain is going to be double the 360. So our domain is going to be 720 degrees. So we now can get 2 more answers down the bottom. We can add 360 to each of our values down here, and we'll have our next 2 answers. We can go and have a look at the tan graph as well and have a look at what's happening, but I'm not going to this time. I'm just going to add on my 360s. So adding 360 degrees to 120 will get me 480 degrees as well. And adding 360 to 300 degrees will get me 660 degrees. So those are my 4 answers for 2x. But we're thinking again, we're wanting to solve. And when we're solving for algebra, we're always solving for x. So what's x going to be equal to? X is going to be equal to half of each of those. So we're going to get 60, we're going to get 150, we're going to get 240, and we're going to get 330. If we have a look at all our values there, are they within that domain that we got to start with, between 0 and 360? Yes, they are. And we're looking like we're right. We can plot each of those into our question as well, just to double check to see if it works out. And that will be another nice way to see if we're right or wrong. Okay, let's have a look at the last question here. Question number 6. 2 sine of 2x minus root 3 equals 0. A little bit more difficult. It's down the bottom of our page. But we're in our normal domain at this point of 0 being between x and 360. But we'll probably be having to change that in a moment when you have a look at we've got a 2x in there. But let's not worry about that just yet. So let's rearrange. 2 sine of 2x, let's take away add root 3 to this side, add root 3 to the other side, and we're going to be equal to root 3. So 2 sine of 2x equals root 3. Let's divide both sides by 2. Dividing 2 on this side gives us sine 2x. Dividing by 2 on the other side is equal to 2. So we've got sine of 2x being equal to root 3 over 2, and it is a positive sign. What we want to have a look at to start with is what our inverse is going to be equal to. So I'm basically thinking of sine of x to start with, or sine of theta. That's what I want to look at. So sine of theta is root 3 over 2. Theta is my inverse sine of root 3 over 2. You can plug that into your calculator, or you can use your special triangles to work out what that is. Okay, and theta is equal to 60 degrees. Now, let's have a look at what else we need to look at. Okay, so we need to figure out in our all stations to central what also is happening in those first couple of angles. We've got sine being positive, so sine is positive in these first two. We've already got our first answer for the first quadrant. It is 60 degrees. Our second quadrant answer, remembering back, is 180 minus our theta, or 180 minus 60. So our first two quadrants answers are 60 and 120 degrees. Now, we worked that out for theta. Remember, I substituted theta in there for 2x. What you could have done all the way along there, if you liked, is I could go back and I could have written, well, that's actually 2x. That's 2x. That's 2x, and that's 2x. That's basically what I've done. So what we need to also do is we need to think about what's happening with 2x. So our domain has to change. Okay, so we have 2 times 0, which is 0. That n doesn't change. But our 360 times 2 is 720. So what we now have is our domain of 2x being between 0 and 720. So what we don't have down here are 2 more answers. So we need to add on 360 to our 60. And that will give us 420. And we need to add on 360 to 120. And that will give us 480. Okay, so there are some answers. However, they were our answers for 2 rotations of x. Well, we just want x, so we need to divide each of those answers by 2, and I'm going to end up with 30 degrees, 60 degrees, 210 degrees, and 240 degrees. And those are all my solutions for x. Okay, that will get you over and having a go at exercise 5H. Concentrate on the ones that I've got written down for you to have a go at. Don't panic too much about the ones in the challenge, but if you do really well at the early ones, please do the challenge. But I don't need you to stress too much if you can't get the challenge ones out this time.